So a committee is formed from 3 seniors, 2 juniors, 2 sophomores, and 1 freshman. All 8 students are seated around a circular table. If the students of the same grade level must sit together, how many different ways are there for the students to be seated? Okay, so on this one, we technically have a group for seniors, we have a group for juniors, we have a group for sophomores, and we have a group for the freshmen. So these groups have to stay together no matter the way you rearrange them. They have to sit together right there. So we actually have only 4 spaces to work with in a circular permutation. Within those 4 spaces, that's where it changes. So we have our circular, so I'm just going to jump back up here and I'll show you the formula that we're using. So on this one, so we're using this formula right here because we can divide it into m number of groups. We can divide it into 4 groups. So even though there's 8 people, we can divide it into 4 groups because they all have to stay together. This is the seniors, this was the sophomores, juniors, sorry, whatever. You get what I'm saying, freshmen. They're all accounted for. They all have to stay together. It's the same group. So technically there's only 4 groups. So that's where we have our 4 minus 1. And in our first group we had seniors. There had to be 3 of them. So within this group there is 3 factorial ways to arrange that. Within the juniors, there was 2 members, so these 2 members can be arranged in 2 factorial ways. Sophomores, again, there was 2 members. There's 2 factorial ways to arrange 2 people. And for the freshmen, there was only 1 person, so it would be 1 factorial. So that's how we would set up this formula, and the reason why we would do that is because in that group, in the circle, they have to stay together, so it really only separates it into 4 different groups. So we had 4 minus 1 factorial times now the number of different ways you could arrange the seniors, the number of ways you could arrange juniors, number of ways you could arrange the sophomores, and the number of ways you could arrange the freshmen. So that's why we use that 4 instead of 8, is because there's only 4 distinct groups. Seniors, juniors, sophomores, and freshmen. So this comes out to be 144. So I guess a good question here would be to ask, how many distinct groups are there? And that's what will help you determine which formula to use.